Assalamualaikum and good day everyone. Today we will be presenting about a topic that is not only important but also powerful, which is solar panel. Our members consist of 5, which are me, Nur Anis, SULAIM, ADLINA, YASMEEN SURAYA and ADLIN NURSYAFIQAH.
For introduction, solar panel. Solar panel are a modern technology that converts sunlight into electrical energy through a process known as the photovoltaic effect. It's a process occurs when sunlight strikes the surface on a solar cell. These solar cells are typically made from semiconductor materials such as silicon, which are highly sensitive to light. The electrical energy produced can then be used directly or stored in the batteries for future use. Solar panels are designed to be installed in various locations, such as a rooftop of homes, commercial buildings, solar power plants, and open areas that receive sufficient sunlight. With their ability to generate clean and continuous energy without producing pollution, solar panels have become one of the most popular and widely used renewable energy sources around the world. Now, we move to significance solar panel. We have 4 significance, which is environmental friendly energy source, reduced electricity costs, decreased dependence on non-renewable resources, and promote energy independence. So, firstly, solar panels are an environmental friendly energy solution. They generate electricity without releasing greenhouse gases or air pollution. This makes them a cleaner and greener alternative to traditional fossil fuel-based power generation. By using a solar panel, we help reduce environmental damage and combat climate change. Secondly, solar panels help reduce our reliance on non-renewable energy sources. Currently, we depend heavily on limited and polluting resources like coal and oil. By switching to the solar panel, we promote the use of renewable energy and support a more sustainable future. Third, solar panel can significantly lower electricity bills. After installation, users can produce their own electricity, reducing their dependence on the grid. Over time, this leads to substantial financial savings, making solar panel a smart long-term investment. And finally, solar panels promote energy independence. They allow homes, business, and even entire communities to generate their own electricity. It's reduced the need to import energy and enhance national energy security.
Now, let's move on the explanation relevant to scientific instrumentation and application concept. Scientific instrumentation is important to monitor and maintain solar panel performance. First, we use solar irradiance meter to measure how much sunlight hits the panel. This helps us to know if the panel is getting enough energy. Next, a multimeter. We check the voltage and current output to make sure the panel is working properly. An IV curve tracer shows how much power the panel can produce and help us to find the maximum power point. We also use a thermal camera to detect hotspot, which can indicate damage or malfunction. Finally, a data logger records all this information over time so we can track the panel performance. These instruments help to ensure the solar panels to work efficiently and safely. Solar panel may have many useful applications in daily life. The most common is for the residential use, where panels are installed on rooftop to provide electricity and reduce electricity bills. They are also used in commercial and industrial buildings to lower energy costs and support green energy efforts. On a larger scale, we have solar farms which generate electricity for thousands of homes and supply power to the national grids. Solar panels are also useful in remote or off-grid areas like the village or during camping where access to the electricity is limited. In agriculture, solar panels power the water pump and fences and even provide shade for crops.
For my part, I will explain how solar panels work based on the science behind them. Solar panels are made up of photovoltaic cells, usually using silicon as the main material. Silicon is a semiconductor, which means it can conduct electricity under certain conditions. When sunlight hits this cell, the energy from the light excites electrons in the silicon. This causes the electron to move, which generates direct current electricity. However, most appliances in our home use alternating current, so the direct current goes through an inverter that changes it into usable alternating current. This process is based on the photoelectric effect, which we learned about, where light energy causes electron to be released from a material. So, overall solar panels take sunlight and turn it into usable electricity using solid physics principle. Solar panels are used in many real-world applications. Most commonly, we see them installed in residential rooftop, where they help lower electricity bills and reduce reliance on the grid. On larger scale, we have solar farms, massive installations that generate power for entire communities. One major example is TMB, large-scale solar plant in Sepang, Malaysia, which contributes to the national energy mix. In remote or rural areas, solar panels are especially valuable. For instance, in part of Sabah and Sarawak, solar energy provides electricity to villages that aren't connected to the main grid. They are also used in public infrastructure like solar-powered street light, bus stop and traffic signals. On a small scale, we even use solar-powered charger, calculator and water heaters. These real-life use show how solar technology is versatile, scalable and accessible, a great example of physics being applied to everyday life.
There are many reasons why solar panel is gaining such attraction. First up is cost saving. Solar panels have the power to drastically reduce or even completely eliminate the bill. Once your system is installed, the solar is absolutely free. Over the lifespan of solar panel system, which can be over 25 years or more, those savings really accumulate and offering a substantial long-term financial return to your initial investment. Next, we have energy independence. This is about taking control of your energy supply. When you generate your own electricity, you are less reliant on the centralized power grid. This means you are less susceptible to power outages caused by the grid failures. As the natural gas or other fossil fuels costs fluctuate, your solar energy costs remain stable and predictable. Next, there's the critical environmental impact. This is perhaps the most significant global benefits, and it's a clean energy source. It's generating electricity from the sun, produce absolutely no greenhouse gas emission, and no air pollution, and also no water contamination during the operation. And by choosing solar panel, you directly contributing to make a cleaner and healthier environment for current and future generation. More benefit is the property value increase. This is a fantastic bonus because studies have consistently shown that the homes that equipped with the solar panel system sell faster and a premium compared to a comparable home without them. From a buyer perspective, they are not just buying a house, but they are buying a house with significantly lower energy bills and already built in and a modern upgrades and a positive environmental footprint. Next, we have low maintenance. Unlike many homes improvements, solar panels are remarkably low maintenance. They have no moving parts, which minimize the wear and tear. The primary maintenance requirement is occasional cleaning to remove the dust, the leaf or other debris that might accumulate and slightly hinder the efficiency, and they are largely can take care of themselves. Finally, the fundamental aspect of being a renewable energy source. The sun is incredibly vast and continuous source of energy. Unlike fossil fuels that are already being depleted, the sun will continue to shine for billions of years. And by harnessing this energy, we are tapping into a truly sustainable power source that doesn't deplete nature's resources or create waste that produce and linger for the century. It's the ultimate long-term energy solution and ensuring the energy availability and environmental well-being for the foreseeable futures. We've talked a lot about the benefits of solar panels. Now let's talk about the challenges that involve on it. Firstly, a high initial cost. The upfront investment in a solar panels can be quite pricey. We're talking about the significant financial outlay that requires careful financial planning because it's a small purchase and it's something you need to budget for effectively. Next is dependence on sunlight. Solar panel performance is directly influenced by the availability of sunlight. This means that on the cloudy days or during heavy rain and of course during night, the panels won't be effective and cannot produce any power at all. And next is closely related to installation is roof suitability. Not all roofs are suitable for the solar panel installation. There might be a structural issue like shading from nearby trees or buildings or simply the wrong angles or material. Some homeowners might even need to make a costly adjustment to their roofing system before they can install the solar panel. Another challenge is potential for the damage. Solar panels are generally robust, but they can be damaged by extreme weather condition. For example, hailstorms, strong winds, or even falling debris. While it's a risk factor that we need to be aware of. Next, then we have installation and maintenance. A professional installation is almost always required for the solar panel, and while ongoing maintenance for solar panels are generally low. It is not entirely maintenance free. You might need to hire a professional for cleaning, inspection, or even replace the downline. And finally, the last point is production and disposal. The manufacturing of solar panels involve energy and materials consumption, and at the end of their life cycle, their disposal can also pose environmental challenges. While solar is a clean energy source in operation, its full life cycle impact is something that we need to continue to address responsibility.
Then I'll be sharing with you some future developments and innovation in the field of solar energy. Let's take a closer look at what the future holds. First, we have solar power and artificial intelligence. The synergy for efficiency. AI optimize solar energy by predicting output, adjusting system, and managing storage based on real-time data. This means that instead of just passively generating energy, solar system will actively learn and adapt. For example, AI can predict when clouds will reduce sunlight and adjust the angle of panels or store energy more strategically. This increases efficiency, reduces waste, ensures reliable performance, making solar power smarter and more adaptable than ever before. For the second one, we explore multi-junction solar cells beyond the limits of silicons. Multi-junction solar cells stack layers of materials to capture different wavelengths of light, catching higher efficiency, usually over 45%, than traditional silicon cells. This innovation boosts energy output, making it ideal for space application and high-performance solar systems. Unlike conventional panels, these advanced cells utilize more of the light spectrum, which is a game changer for environments where every bit of power counts, like satellites, solar-powered aircraft. And the third one, we have transparent solar panels, reimagining urban architecture. Transparent solar panels turn windows and glass surface into energy sources without blocking light or visibility. This innovation can transform buildings into self-sustaining energy, efficient structure, revolution urban design. Like imagine a skyscraper where every window not only provides a view, but also generates electricity. This could drastically cut down on the energy footprint of our cities. Smart solar panels, the future of automated self-optimizing energy. Smart solar panels use AI and LOT to monitor and adjust performance based on weather and energy needs. This automation maximizes efficiency, reduces maintenance, ensures reliable, real-time energy generation, and storage. Essentially, smart panels are like having a brain for your solar system. They automatically optimize themselves without human intervention, which means better performance and lower costs over time. Finally, we have bifacial solar panels. Harnessing light from every angle, bifacial solar panels capture sunlight from both the front and back, increasing energy output by using reflected light. This design boosts efficiency, especially when installed on reflective surface like rooftop or ground-mounted system. It makes great use of light that would otherwise be wasted, maximizing the space used for solar energy collections. In conclusion, solar panels are a powerful and sustainable solution for generating electricity by converting sunlight through the photovoltaic effect. Their versatility in installation and ability to produce clean energy without harmful emissions make them an essential technology in today's shift toward renewable energy. As global demand for eco-friendly power sources grows, solar panels continue to play a vital role in building a cleaner and greener future.